Dr. Dave Purcell, and this morning we're going to talk about transferring or measuring out quantities of liquid materials. Now we have three basic ways that we'll do this in the organic chemistry lab, and we'll select the method depending on whether we need to know precisely how much liquid we're transferring or whether we need to know approximately how much we're transferring. So let's first talk about precise transfer of liquid. And to do that, we'll use an Eppendorf automated delivery pipette, commonly called the ADP. The ADP that we typically use measures 1,000 microliters, which is equivalent to 1 milliliter of liquid. The calibration can be changed anywhere between 1,000 microliters and 100 microliters, still allowing us to draw a very precise quantity of material. The ADP is used in conjunction with a disposable pipette tip. You'll see throughout the lab that we've got boxes with the pipette tips deployed, ready for your use. So now I've got the ADP and pipette tip. It's very important that I keep the ADP in an upright position as opposed to a horizontal position. When it's horizontal position, any liquid that I've got in the pipette tip will run into the ADP and corrode the mechanism in the ADP that enables it to draw liquid up. So with the pipette tip in the upright position, I'll move to a reagent bottle where I want to draw precisely 1.00 milliliters or 1,000.00 microliters of liquid. So in order to draw the liquid up, first I'll depress the thumb detent on the pipette. I'll move the ADP over the reagent bottle and submerge the tip into the liquid. I will then slowly raise the detent, and as you can see, I have drawn up exactly 1 milliliter of reagent into the ADP. I'm going to put it into this conical vial, and recall that we always like to support our conical vials in beakers. So to move the liquid from the ADP into the conical vial, I lower the tip down below the edge of the vial and I slowly push the detent. Once the liquid has been extracted, I move the pipette up. You'll notice that there is one remaining drop in the pipette tip. The pipette tip is calibrated to leave one drop remaining. Don't feel compelled to get that last drop off. Right, I move my pipette tip over to the side and I can extract the pipette tip by pushing the thumb detent. So in the second technique, I'm going to use a plastic disposable calibrated pipette in order to draw an approximate volume of liquid. You'll notice on the pipette there are calibration markings. These are approximate. The top marking is for 1 milliliter. So I want to draw approximately 1 milliliter of my reagent into the disposable plastic pipette. I dip the pipette into the reagent and I draw up liquid until I'm at the 1 milliliter line. I move to my container and I push the liquid out of the disposable plastic pipette. So many of the experiments we use will require approximate volumes of organic solvents in order to conduct the experiment. So the disposable plastic pipette is the most efficient method of determining approximate volumes. In our third technique, we'll use a glass pipette to remove liquid. The glass pipette is specifically designed to fit into the bottom of the conical vial and also the bottom of a centrifuge tube. In this case, I've got a centrifuge tube that has two layers of material, an aqueous layer on top and a very small organic layer in the bottom. I want to remove this organic layer from the bottom and transfer it to my conical vial. So first I'll put my conical vial into a beaker to provide it some stability. I'm going to depress the squeeze bulb so that I've got vacuum. Then I'm going to move the pipette all the way into the bottom of the centrifuge tube. And now I'm going to very slowly draw up the bottom layer of organic material. Once I have all of the organic material, I'm going to pull the pipette out of the centrifuge tube and then squeeze the bulb. So I've now transferred my small organic layer into the conical vial. So in summary, we have three different techniques for moving liquids from one container to another. When I need a very precise measurement, I can use the Eppendorf ADP. Again, calibrated very precisely. The common volume we'll use is 1,000.00 microliters or 1.00 milliliters. If I need only an approximate volume of liquid, I can use the disposable plastic pipette that has approximate calibration marks. And when I need to transfer liquids from conical vial and centrifuge tube, I use the glass pipette, which has a very fine tip that fits nicely into the bottom of the conical vial or the centrifuge tube.